In this video, we're going to do a little trig review of sine, cosine, and tangent. If you have a right angle, then you can find the sides, the length of each side, and you can find the angles using sine, cosine, and tangent. So if you remember SOHCAHTOA, that stands for sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent is equal to opposite over adjacent. So what you would be using sine, cosine, and tangent for is to find the length of the sides of a right triangle. Has to be a right triangle. You can also use them to find the angles of a right triangle. We're always going to be talking not about the right angle, but about the other angles. So in this setup here, I know that my hypotenuse is 10, and I know that my angle here is 20. And if I'm looking for this side or this side, I have enough information that I can use sine, cosine, and tangent to figure out what those sides are. So with my right triangle, if I'm looking at this angle, then this is the opposite side to that angle. This one is adjacent. So let's say I'm going to try and find x. So I am looking for the adjacent. So that goes with cosine. So if I set this up, cosine theta is equal to adjacent over hypotenuse. So cosine of 20 is equal to, I don't know my adjacent, but I've called it x over my hypotenuse, which is 10. If I use algebra to rearrange, I'm looking for my x. So I'm dividing by 10, so I need to multiply each side by 10. So I'm going to multiply this side by 10, I'm going to multiply this side by 10. That goes away, and I end up getting x is equal to 10 cosine 20. And when I put that in my calculator, I get 9.39 or 9.4. And my unit here was meters, so this is 10 meters long. And so this side here is 9.4 meters long, which means this one's a pretty short side. Now, if I'm looking for this side, I could now use tangent, since I know this one, but I'm just going to go ahead and use sine. It's opposite. And so I can use sine, because this is opposite and I have my hypotenuse. So sine theta is opposite over hypotenuse. And I plug my numbers in. Sine of 20. Make sure that you're using, this is 20 degrees. So if you didn't get this in your calculator, you need to change your calculator to degree mode and not radian mode. If it's in the wrong thing, it will give you the wrong answer. But that could have been your problem if you didn't get that. So sine of 20 is equal to opposite, which I don't have, but I've called y, over adjacent, or excuse me, over hypotenuse, which is 10. And again, I rearrange this the same way, and y is going to be equal to 10 sine of 20, which when you put in your calculator, you get 3.42 or 3.4 meters. 3.4 meters. So now I know that this side is 3.4, this side is 9.4, and that side is 10 if this is a 20-degree angle. What is this angle? Well, I don't have to do any fancy math for it. I just have to remember that all of the angles add up to 180. If this is 90, because it's a right angle, and this is 20, then that leaves this one being 70 degrees. So let's look at this situation. For this one, I have two sides of the triangle, but I don't have my theta. I do have my opposite and my adjacent. So this one is my opposite and this one is my adjacent. So that leads me to believe that I could be using tan to find this out. So tan theta is equal to opposite over adjacent. If I rearrange this for theta, I can't just divide by tan to get tan on the other side. The opposite of tan theta is inverse tan. So theta is going to be the inverse tan of opposite over adjacent. That's how you use that. So if you're looking for the angle, then you're going to do the inverse of tan, or the inverse of sine, or the inverse of cosine. So my theta is going to be the arctan of opposite over adjacent, so 12 over 8, which is 56.3 degrees, or 56 degrees. So this is a 56-degree angle right here. And now that I know my angle, I can easily find the other angle. So 56 to 90 is going to be 34. So that one's 34 degrees. And if I want to find my hypotenuse, I could do sine, cosine, or tan of either of these angles to find the hypotenuse. The other way I could find the hypotenuse, remember Pythagorean theorem, to find the length of the hypotenuse, it's use Pythagorean theorem. So a squared plus b squared equals c squared. And this is c, your hypotenuse is the c. So c is always going to be the square root of a squared plus b squared. And so I'm doing the square root of, it doesn't matter which one's a and b. So the square root of 12 squared plus 8 squared is equal to 14.4. And the unit here is newtons. It doesn't have to be a distance. And so this is 14.4 newtons. So hopefully that was enough to jog your memory to get you going so you can do all the problems that you need to do in physics this year, because we will use this a lot. Okay.